All right, I will try to do this in time. So, the deep lens. The reason why we're playing around with it is to see if we can do anything new that somebody else haven't done within our area. And part of it is to make sure that the business understand what it can do. And by doing that, we're trying out the concept to make people come into the office and don't use a badge, use their face instead. And the deep lens itself, it was released last re:Invent. I'm not going to talk too much about the actual, but I'll step it through basically. It's over there. It's a bit buggy, just so you know. It lost Wi-Fi apparently here, so I'll reboot it meanwhile. But it's basically it's a Intel machine with a GPU that can do 100 gigaflops, and it's running a Ubuntu. If you connect your HDMI to a screen, you will see it's a Ubuntu desktop basically. The good thing is that you don't need to, like if you do this stuff with Raspberry Pi, you need to install the Greengrass stuff and you need to connect it to the Wi-Fi and blah, 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 blah. This one, if you unbox it, it will pop up with a network. You can go in there and anybody with a suit can configure it basically, and that have AWS access. It's a bit slow though, doesn't really say the CPU performance here, but you need to understand it's a slow device, but with a GPU that will offload the stuff for you. But it's 2 cores and it's Intel Atom 1.3 gigahertz. It's have a special deep lens console, but it's basically duct tape around the SageMaker and the Greengrass services. But it's working quite good if you don't try to do too advanced stuff. So you can deploy the models and Lambda functions through the deep lens console, and you click deploy and it will just throw it out when it's connected to internet. And the device itself, it can only run one model, and not super duper advanced, but and you can run one Lambda function out of the deep lens console as a standard, and you get 2 outputs. One is a device stream, one is a project stream. Basically what it means, the device stream is the video itself that the camera shows. The project stream is what your Lambda function is doing on the actual video stream. So you can debug it if you put in debug messages in the video itself. And it puts the project stream to TMP resolves JPEG, so it's basically a JPEG file that just overwrites and you have a browser that reads it out for you. It's Python 2.7, and yeah, only one model. And the device itself, you can browse to it, you can SSH to it if you enable it. Protected with a client certificate on the web browser side if you want to debug the actual video stream. Problems, because it comes with a fair bit of problems. There is a reason why it's called DevKit. It's a slow CPU. As I said, one model you can run on it. State, you need to figure that out yourself. If you trigger something based on a cat or a dog or a hot dog, for every frame it reads that, it will do what you say the code should do. And the workarounds is to hack around and put a file in some sort of TMP and try to figure out the state. You don't have like any database services or something like that running on it. You cannot run multiple lambdas. Matteo helped me out with this part. He was he found a way on a deploy one lambda through the Greengrass console. As I said, it's duct tape around the Greengrass and SageMaker. So it was super good when you figured that part out. But the problem comes then if you're playing around in the deep plans console, it overrides the settings you're doing, like the hardware access, and like you need to give greengrass access to sometimes to some system parts. And if you play around with the deep plans deployed through there, you will just overwrite it. Heating problems. You can most likely, if you don't put a throttle in the way of how you're handling this, it will shut down automatically after 2-3 days. And then I haven't found yet any part to start it again. Someone needs to go and click the button. So there is no wake on long or stuff like that, what I've seen. I haven't been able to go into any BIOS yet. Yeah, and AWS states it's do not run this in production. It's a dev kit, so but they are though. If there is a real case for doing this in production, they will be very, very helpful to try to figure out what's your use case and try to find a hardware that will fit your case. But then you get back to you need to deploy greengrass yourself and the Wi-Fi stuff and blah blah blah. It's quite nice with the deep plans on that side. And you have some ready-made projects that does everything for you. You can just put up the console and deploy a project, and you can see that it's working. Here are some different ones. Identification of if it's a hot dog or not. There's a quite fun one, Simon says, where it will identify if you do the right movement as you're supposed to do. And the doorman. We use the doorman, and we modify that one for this test, but I will go more into that soon. But if you decide to go the hard way, SageMaker is quite nice. It's super nice. Easy also to get a notebook with Jupyter, and it works. It's really good, and there is tons of examples. Then you can decide if you want to train stuff from scratch or use a current model and do the training on objects based on that. The later one is the most recommended one. And then you create the image set and just throw it in a bucket, and you make it train. It's quite nice. It's in the background it's running a Docker container and do the training and stuff like that. And when it's done, it shuts down. So you don't need to worry about a super expensive build because you start up a GPU instance. But most likely you will be waiting a bit of you doing the training, and then you have the what the fuck moment if when stuff doesn't go as expected. It's quite hard to debug, at least for me. If you use the easy way, you use one of the projects, either the official one or the community one, and you use the deep lens, most likely as AWS want you to do. You do some stuff there, and then you throw the rest to the cloud. Yeah. So you do the stuff in the cloud, pay some money to AWS, but it will simplify life. You will be a lot faster in your projects because it's a bit tricky to do everything on the device itself. It's not meant to do that, but you can do that. It's still an OS running on it. So as I said, we use the doorman one. It's a project that is supposed to be close a door, and it will notify anybody it doesn't recognize on Slack. And when it recognizes somebody on Slack, it will also say, like, oh, hi, Mr. Blah Blah. So we use that one. God damn it. Okay, cover your eyes. God damn it, wrong order. So we modify this. I will show the diagram after. So we Material helped out to modify this to get it working with Teams, Microsoft Teams. It's similar as Slack, but there is a lot of more stuff around it. It's not just chatting. It's all about the Office 365 suite and blah. So what it does, it pops up a message in a channel if there is somebody that doesn't recognize. and we get a string field where we can tell tell it like this is, in this case, his name is Philip, and when we have done that input, it will say after a while like, okay, now I know Philip. And then I have a demo of working, when it's identifying me. So I have it in the back of my desk and show my face, and it will pop up and tell, okay, hi, Lezgin. A little slow there. Yeah, but there you have it. So, as I said, it doesn't keep any state. You need to handle that yourself. It's quite hard to do it on the device. So if you have it in front of you for too long time, it will just fill the channel with a lot of pictures. Every frame you can manage capturing. It's like anything between 10 to 15 frames. And then we wanted to use this to open the door. Was trying to reverse engineer the alarm system itself. Really crappy system running like some fake AES encryption over HTTP. So it was like too much to bother. It was like a Java applet and stuff like that. So it was like, okay, let's skip this and bring the toolkit. And we used a project called 9 in Python, where you basically can communicate to the device itself and over USB and run Python code. And the reason why we didn't use a separate green grass was to keep it simple and like isolated, just for our first test. So yeah, it's supposed to be 5 volts, not really 5 volts, but yeah. And then we managed to get this working. You will see the duct tape with the camera there. Keep it in the air. And you will see that the door is closed. Show my face and quickly go away. Because it will, so it doesn't like try to open the door too many times. And then it's open. But yeah. Oops. And yeah, let me just see if I will show you the diagram of how this is working. Some reason, yeah. Okay. So basically, it's what it does. The doorman one, when it identifies a person, it sends the picture itself to the AWS recognition service with the numbers we have here that is triggered. And this is the original diagram with Slack, and then we, as I said, we put Teams there instead. And then the second phase, PowerPoint. There we go. And last state is have the separate lambda for actually triggering the relay, USB relay there to open up the door. And then we have something else going on. The reason why it's not put up right now is I don't want anybody to come into this office by showing my Facebook pictures. So we need a second factor about it. It's not many that's thinking around that type of problem, but I'm a security geek. So we're working on to get a second factor, which we have 37 access points in this office, so we can do triangulation and stuff like that to see if somebody is at the elevator shaft. But it's not working that good because not all the function is exposed. So we're trying to figure that one out. We need to have a proper secure second factor, else we're not going to really have this up and running. Maybe during the lunches. But the goal is to have this up and running and had the business to try to get a feeling of more on the machine learning side. And that's how far we have come. Sadly, the device is not connected to the Wi-Fi. There have been some Wi-Fi problems with the device itself. In the beginning especially, now it's been good, but for some reason it doesn't really work. And the reason why I cannot do a demo is because I don't have a door here. Else I will be super happy to do the demo. But yeah, it's a little bit tricky to debug in general, but it's a fun device to play with. And yeah, during the summer there was a lot of stuff trying to not use the ready-made project, and that was a bit tricky. Because yeah, you need to have a fair bit of knowledge, even if it's SageMaker is super nice. But it's, as I said, it's quite hard to debug when something goes wrong. Any thoughts, any questions? We want to have a break, and then Adrian will talk about a recap of re-events and some demos. Cool. There is still some beer and food, I believe, so make sure we don't need to throw that away.